Hey astrophysicist, this video is just for you, so if you're not the astrophysicist, you clicked on the wrong video. So if you haven't already, you need to get your composition notebook. And also, if you haven't already, you need to get the vocabulary papers for your flip, like this, okay? Because I want to go over those definitions with you and make sure that you glue them in appropriately. Okay, so if you need to, pause the video and cut those things out. Get ready, because here we go. We're going to go over those, and I'm going to have you add some things as we go through them. Okay, all right. So you're gluing that on page 2 of your composition notebook. So it's the back side of where we glued our standards. And if you were absent or something like that, then you need to go back to September 11th videos and check that out. Or you can probably ask somebody and they can help you. Okay, so page 2, you got it all glued. For rotation, we want to check it. It's moving or turning around a center point. And we've already talked about that in our small group, in our workshop, that rotation is this spinning here. And a key fact that I want you to write down is that it rotates from west to the east. And if you think about it, that's a little strange, because the sun, it rises in the east and sets in the west. Well, really, it's because Earth is spinning from the west to the east, like towards the sun. So the east is the first place that gets hit by the sun's direct rays. Okay, and then as we rotate, remember rotate gives us the date, okay, takes 24 hours, that's a day, all right, and so here it is, we're spinning from the west to the east, okay. So if you are standing on the North Pole, it's going counterclockwise, but if you're standing on the South Pole, it looks like it's going clockwise. You may have seen some pictures of that recently. Okay, rotation. Did you write those things down? If not, rewind it, pause it, go back. All right, revolution. Moving around something else in a path like a circle. Okay, so the Earth goes around the sun. So if my head is the sun, revolution is around like this, okay, goes in that circle. It's more of an elliptical path, not a circle, okay, kind of like if you scrunch the sides of a circle, okay, or like an oval. And another word for this is orbit, okay. All right, again, pause if you need to, rewind, okay. Tilt. When one side is higher than another side, not straight. So if you watch the PowerPoint, then you had a yes-no page, and some of you were really confused about that. So the axis is not up and down straight like this. It's tilted. It's at an angle. And what is that angle? 23.5 degrees. Write it down. Write it down right on top of that definition. Okay? 23.5 degrees. And again, don't forget, if you need to, rewind, go back. All right, axis. So what is this? Well, yeah, that's a toothpick, but what I have here is the toothpick that's showing the axis, but it's an imaginary line that something like Earth spins on, okay, or rotates on, okay. There we are, there we are, okay. Gravity. Gravity is a natural force that causes things to move toward each other. It's like a magnet, and it pulls things. So on Earth, we have gravity that keeps all the water and all the land and all of us on it, so that as it is rotating, guess what? We don't fly off into space, because if there was no gravity on Earth, then we would be flying around in space. Well, we probably wouldn't be here, but yeah, okay? So gravity, it's that magnetic force that pulls things towards the Earth. We're going to talk about that a little bit later with the moon too. Okay, orbit. It's a curved path that one thing follows, okay, a celestial body like a planet or a moon or, you know, the outer space pieces, okay, celestial bodies. That a curved path that those celestial bodies follows as it goes around something. So remember, Earth follows this orbit. It orbits the sun or it revolves around. Okay? All right, mass. Mass is the amount of matter in an object. So matter, everything is made up of matter, and like stuff, okay? And I know you're not supposed to use that word in humanities, so don't use stuff, but I know you understand what I'm talking about. If I just say stuff, it's made up of stuff, all right? And so if you think of a ball, okay, let's think of a bowling ball. Okay, a bowling ball has lots of stuff inside all the way to the outside. It's solid, right? And so it has a lot of mass, a lot of stuff inside of it. But a soccer ball or a basketball, it doesn't have a lot of stuff in it. It has air in it, okay? So that if you just think about the rubber or the plastic that is made up of that ball, that the ball is made up of, then it doesn't have a lot of matter, okay? So bowling ball has lots of mass, it has lots of stuff in it, okay? But a soccer ball or a basketball or a volleyball doesn't have a lot of stuff inside of it, so it has less mass. Now a lot of people think weight and mass are the same thing, but no, they're not. Weight is that gravity pulling on the mass, okay? So if a bowling ball, because it has a lot of mass, has a lot of pull because of gravity has a lot of pull on it because there's a lot of stuff that it can pull on. But a basketball or a volleyball or a soccer ball doesn't have a lot of mass, and so there's a less pull of gravity on it. Okay, I think I used this example in our mini workshop that we had where there's less gravity on the moon, and so I am made up of this amount of mass, and so I go to the moon, I'm still the same mass, okay? But my weight is different because the gravity is a lot more on Earth. I'd rather weigh myself on the moon because it's less. Okay. All right, the next one, season. A time of year when we have certain weather patterns because of the position of the Earth. And it's basically because of the sun's rays that are hitting the Earth. Okay? So here, the sun's rays are hitting us. We're getting more direct. Okay? But if it's over here, then it's going to be here. And then the sun's rays are going to take a lot longer to get to us. Whoop. Okay, seasons. Don't forget to pause if you need to. All right, equinox. So we're coming up to an autumnal equinox. And what that means is that the periods of daylight hours and the nighttime hours are equal. Equinox, equal. Okay? Now we're not talking about exact minute. Okay? So, but it just feels a lot different. Okay? Solstice is when they're not equal. So in the summertime, we have the summer solstice because there's lots of period of daylight hours and a little bit of nighttime. You can be outside playing at 9 o'clock and it's light outside in the summer. Okay, and when you wake up in the morning, it's light out. So there's this little period of darkness. But in the winter, so we have the winter solstice. In the winter, it gets dark early and it stays dark a long time. So sometimes I'll be at school until like 5 or 6 o'clock and it's already getting dark. What the world? Okay, so solstice. Autumnal equinox is coming up, and then we also have a spring equinox. All right, so those are your vocabulary words, and if you've got those, then you're ready for the next task. Okay, go Hawks!